Hey, Bo, you want to swing? How do I get you to move? How do I get you to move? I have to push you. So how about if I give you this much push? Is that enough?
No.
Why not?
Because I'm higher.
So if you want to go higher, what do I have to do?
Push me way higher.
So I have to give you a bigger push and then you'll go faster? All right, so if I give Bowen a bigger push, then he accelerates more. So greater force makes for a greater acceleration. So Newton's second law has two parts. The first one is that increased force causes increased acceleration. When we talk about increasing force, we're talking about a greater push or pull. And this will cause objects to increase their acceleration, and acceleration means changing their velocity, so speeding up, slowing down, or turning, remember, because direction is a part of acceleration. So if I throw the ball with a little force, it goes with a little acceleration, and a big force makes a big acceleration. If Bo here gives a little push on the ground, then he accelerates or starts to move a little bit. And if he gives a big push, then he accelerates a lot more. So greater force, greater acceleration. I have Bowen and I have Macy. So if I give them the same amount of push, what happens if I push you guys the same? What do you think? Why? Part 2 of Newton's second law is that increased mass causes decreased acceleration. So what that basically means is that heavier things are going to change their motion, speed up, slow down, or turn a lot less easily. It will take a lot more force to change the motion of a heavier object. For example, if Macy here tries to throw a bowling ball and a baseball, the bowling ball accelerates a lot less slowly than the baseball does because it has more mass. Okay, so if I give you guys the same push, then look what's happening. Bowen is swinging faster, a little bit more, than Macy is because she has more mass. So when we increase mass, when we increase mass, we decrease the acceleration. In order to get them to stop, if I want to stop Bo, boop, just a little stop. If I want to push stop Macy, it also takes more force to slow her motion down. It also takes less force to get a soccer ball moving than a sometimes a relatively small mass and a relatively small acceleration will be enough force to bust up the tile. Small mass, small acceleration, little bit of force. If I need more force, I can take my small mass and I can give it a greater acceleration and get more force, right? But sometimes this small mass, even with the most acceleration that I can handle it and still be, somewhat accurate, isn't going to be enough force. This is going to have a limit with the amount of acceleration I can provide. And so I'm going to have to bring out the big guns. And that is going to give me more force with less acceleration. But if that's not enough, and I need even more force to bust up these tiles that are like really, really glued down here, then I'm gonna have to take this greater force with a huge amount of acceleration so that I can provide enough force to really bust up these other tiles. So busting tile is an exercise in Newton's second law. How much force do I need to break up these tiles will determine which mass I'm going to use and how fast I'm going to accelerate it.